cylinder that has a randomly generated directional input on an object. It's going to give kind of like a recoil effect, or depending on how intense you want it, you can also make sparks that have collision. So let's get started. First we got to make our own local axis for the logic that we are going to be building. So we want to pull out a cube to paint on. Stamp the cube down, exit. Go into paint mode. Make sure your paint is on white, and if you haven't already got it on, make sure surface stamp is on. Make a plus sign on the cube. Make sure it is equal on both sides. Make sure it is centered. You can exit out, delete the cube, duplicate the cross, turn it 90 degrees. Combine both of the crosses together to make one painting. Next, to make it easier to see, let's make it glow a bit. Now that we've got our axis, we can start making our cube and cylinder. Make a cube and scale it down. Put it on the bottom half of the axis. Alright, now we want to make a new sculpt. Pull out a cylinder, or it doesn't need to be a cylinder, but as long as it is long and narrow. Turn it vertically, stretch it up, stamp it down. Next, we want to pull out 2 microchips. I like labeling them, so I'm going to make this one as a transition and this one as an effect. Stamp the effect microchip onto the top of the cylinder. Next, move the cylinder to the center of the axis. And be sure that it is snapped to the grid by holding down R2 and pressing triangle. Alright, next we want to parent the cube to the cylinder with a joint, a ball joint, and make sure that you connect it at the center of our local axis. Turn on X-ray so that way we can see our ball joint, and move the ball joint to the center of the axis. Now we can start working on our logic. Open up the transition microchip at the top of the axis. We're going to pull out a trigger zone. Open it up. Set it to tag. Detection scope to here. Go into zone size and make it a cube. Move that trigger zone's center to the center of our axis. Hold R2 triangle to snap to grid. Next, move it to one side of our axis and thin it out. Next, you want to go to the zone fall off of that trigger zone and scale it up so that way it reaches to the center of our axis. Do not go past, so that way, otherwise it will overlap with the next trigger zone that we are going to be putting. We still want to have a 0 output. Duplicate it and move it to the opposite side of the axis. Open up the previous trigger zone to compare distance at the center. Make sure that they are not overlapping, and make sure that they are not too far away. This is a suitable distance for us to use. Duplicate it a third time, move it towards the center of our axis, turn it 90 degrees, and then move it to the side. duplicate it again, and then move it to the opposite side. Duplicate it again, so that way we can get our z-axis. Move it to the center, turn it 90 degrees, and put it to the top of the axis. Duplicate it once more, move it to the opposite end. And be sure to make sure that they are not overlapping and they are at a decent distance from away from each other. Now we can move on to the next. Next, we're going to pull out some tags for those trigger zones to detect. Open up the tag, make sure that its vertex is at the center of our cylinder. This is the X, this is the Y. Correction. This will be Z, and this is Y. That's Y, and this is Z. Now we need to label our tags to the respective tag zone. This is the X-axis, so we're going to name them X and negative. We're going to name two tags, X and negative X. Next will be the Y-axis. And then the Z-axis. Now that we have our tags and their names, we can assign the trigger zones to their tags. This is X, negative X, Y, negative Y, Z, negative Z. Done with that. Now we can move on to the rest of the logic. Let's pull out a value slider so that way we can see our tags values. Make it -1 by 1. And minimize its view. I'm going to make 6 of them in total. And then plug in the tags to their respective value slider. Now we can pull out an emitter. Turn emit speed to 10. Turn on time between emits as 0. And make the limit to 60. Pull out a calculator. We're going to make this a multiplication calculator and make it multiply by -1. Duplicate it twice. Connect the negative values into the operand 1 of the multiplication calculator. Duplicate the value slider, and then duplicate it 2 more times. Connect the result of each multiplication calculator into their respective values, and then do the positive values into their respective values. Just so we can see the end result of this part of the logic, we can pull out a combiner, make it a rotation, and the rotation input as an axis and angle, and connect each value to their sign, X, Y, and Z. Open up your emitter, go to inputs and outputs, connect the output of your combiner to space, scene, direction. Pull out what you want to emit. And assign it as the emitted object. Make sure the emission point is on the top of our cylinder. So that our cylinder doesn't rotate on its own, let's pull out an advanced mover. Set the speeds, all speeds at 0, and can make movement strength and damp on all axes to 100%. It's not strong enough, so let's make it to 20. There. Now let's test out the directional input by rotating our cylinder. Looks like it's emitting the right way. Good. Now we can move on to the next step. Pull out another microchip. Pull out a node so we can make an input node and an output node. Connect our combiner to the input node. Pull out a splitter. Connect the input node to the splitter. And assign the splitter as a rotational output of as an axis and angle. Pull out a value, actually just duplicate the other value sliders, make 3 of them. Connect our splitter into the 3 value sliders. Just duplicate them again. Pull out a signal generator, put it underneath one of the first value sliders, and make it a negative 0.1 by 0.1. Sweep seconds as 0. Duplicate it twice. Next, pull out another calculator. It's going to be an addition calculator. Connect the generator to the operand 2 and the value to operand 1. Connect the result into the final value slider. and duplicate our calculator 2 more times and repeat. Pull out another combiner and then connect the values to the respective sign. Now we can minimize it. Now we can connect, go to input and output on our emitter, and then connect the output node to our scene space direction. There you have it.